Welcome back to Honors Calculus. In this video, we're going to start into lesson 4 on the derivative with a discussion of the tangent line problem. The geometric definition of a tangent line is a line that passes through a particular point on a curve, as well as the next consecutive point. Of course, the idea of the next consecutive point doesn't really make a lot of sense on its own, so we have to do some work to get around that. So we go to a formal definition. The line tangent to the graph y equals f of x at the point x equals c is the line through the point c f of c and through this odd construction c plus delta x f of c plus delta x for some delta x going towards 0. Right, so finding the equation of a line, we need y minus y naught. Y naught will be f of c equals a slope m times x minus x naught. X naught will be c itself. And so the interesting thing is m. And for m, we need to use both points. So since we're looking at x goes to 0, we'll take a limit as x goes to 0 of change in y, f of c plus delta x minus f of c all over change in x, c plus delta x minus c. And notice in the denominator, you have a c and a minus c, which will cancel each other out. And here we see the power of the limit. Having spent a week looking at what limits are, this is why they are useful. Because I want delta x to be vanishingly small, practically 0. But delta x is in the denominator of a fraction, and dividing by 0 is a problem. So the entire point of this machinery of the limit is so that we can write this equation and have a way of dealing with this divide by 0 issue that comes up from it. There are a couple of notations you can use for this limit. If you think about slope in general as some change in y over some change in x, because we're looking at this infinitesimally small change in x, right? X plus delta x. Though we'll denote this infinitesimally small change as a dy over dx. And if we want to be specific, we're evaluating this at x equals c. That's one of two notations that are used for this idea. Each one has a slightly different context. We'll get to the other one in just a minute. But for right now, let's just dive in. let's find the equation of the line tangent to y equals x squared minus 7x at the point x equals 2. Well, from the definition of the tangent line, we're going to need to evaluate y at x equals 2. Right? 2 squared is 4, 7 times 2 is 14, and 4 minus 14 is negative 10. So we know we're going through the point to negative 10. The other thing we need is our slope, which we could write as m, or we could write as dy dx at x equals 2. But either way, it's going to be the limit as delta x goes to 0 of the function evaluated at x plus delta x, which is going to take this strange form. We're going to have x is 2, so it'll be 2 plus delta x squared minus 7 times 2 plus delta x minus the value when we put in 2, which we already know is negative 10, all over delta x. And our goal is to be able to reduce this fraction. Which thankfully we can do. If we multiply out 2 plus delta x squared, that's going to be 4 plus 4 delta x plus delta x squared. If we multiply out minus 7 times 2 plus delta x, we're going to get negative 14. We're going to get minus 7 delta x. And then we have a minus negative 10, which is just plus 10 all over delta x. Combining some like terms from here, we have delta x squared. We have a 4 delta x and a minus 7 delta x. Together, that's minus 3 delta x. And we have a 4 minus 14 plus 10, which all told is 0. All right. And now every term in the numerator has a delta x, so we can divide numerator and denominator by delta x. And now we're looking at the limit as delta x goes to 0 of delta x minus 3, which we can just evaluate by plugging in 0 for delta x. We get 0 minus 3, which is negative 3. All right. So we need the equation of a line with a slope negative 3 that goes to the point we came up with earlier, to negative 10. And that will be y minus y naught, which is negative 10, equals the slope, negative 3, times x minus x naught, which is 2. And we can simplify this. To get y equals negative 3x minus 4. In the past, there have been a number of applications for which finding an equation of a tangent line like this are important. For our purposes right now, we're going to stick with just we have a tangent line and that's great. Right. Here's a similar problem for you to try. Using our limit definition of the slope of a tangent line, I would like you to find the equation of the line tangent to the graph y equals 12x minus 3x squared at the point x equals 1. Take a few minutes, see where you can get with that, and I'll see you in the next video.